All right, guys, so this is going to be a quick video. Basically, what I'm doing today is I'm just recapping. We're starting to kind of get into a review kind of mode, just make sure that we have everything that we need to know for the next test, which is going to be Thursday of next week. So the first thing that we covered was going to be ions. So ions are going to be charged particles, meaning that they have basically a positive or a negative charge to them. This happens when electrons are either gained or lost. Gained or lost, okay? So make sure that you know that it's electrons that are changing, not anything else. If an electron is added, it is going to be a negative charge, and we call that an anion, okay? If it is lost, then it is going to have a positive charge, and that is going to be a cation. So cations are going to be positive, and then anions are going to be negative. So in general, the things on the right side of the chart, those yellow over there, those are all going to gain electrons because, again, everything wants to get into this noble gas configuration. It wants to be like this last row. So they're going to gain electrons. And when they do that, they end up becoming anions, whereas over on the other side of the chart where your metals are, those end up usually becoming cations because you just have to lose a couple of electrons and now you are in noble gas configuration. So that's the gist of ions. One other question would be, if I were to give you an element, you should be able to tell me what type of ion you make from it. So for example, let me go ahead and clear my board real quick. Okay, so let's say that I give you something like fluorine. Fluorine is right here. The way that you would figure out what kind of ion it's going to show is to see where it is on the periodic table, and you can even draw out some diagrams. So fluorine is going to have 9 protons, it's going to have 9 neutrons. It's also going to have 2 shells, and it's going to have 9 electrons. 2, 3, 4, 5, 6, 7. Oh, that's good. Okay, yeah. So because we got 2 of them inside. So you have something like that. Now notice that you're going to have room for 1 more just for a full octet. You only need 1 more electron there. So that means I'm going to add 1 electron. And when that happens, I'm now having 10 negatives because electrons are negative, and I have 9 positives because protons are positive. So you end up with a -1. So you would show this as fluorine minus, like that. If you were to do a cation on the other side, like magnesium, that one's going to lose 2 to get to its noble gas configuration, and you would give it a charge of +2. It's the same principle that applies. It's just working in different ways using your information on the periodic table. If you have any questions about this, go look the videos up from week 1. That is when we started talking about this. So the other key thing that's going to be important to understanding how you make these diagrams is going to be valence electrons. Valence electrons are electrons that are in the outer energy level, okay? So make sure that you can find that. So for example, if I take carbon right there, carbon is going to have 6 electrons total, but you have 2 that are in the inner energy level, and you have something like this for the outer one. So the more you practice this, I would actually just encourage you to look up and draw Bohr diagrams or Lewis diagrams for a lot of these elements, and you'll get this quicker the more you practice with it. But electrons in the outer energy level, the other way that you can do this is the kind of quick notes way, 1, 2, 3, 4. That's the way that you can kind of spark notes it and figure that out that way. So carbon is going to have 4 valence electrons, okay? So valence electrons, remember, are only the ones that are in that outer energy level, and they're the ones that are forming bonds, that are transferring if you're talking about ionic bonds, and all of that good stuff. Okay, so then from there on, we talked about how do we form compounds. To form compounds, you have to have a bond between 2 atoms. And if we're talking specifically about this word compound, we're talking about different elements. That's going to be the difference between a compound and a molecule. Molecules can be two atoms that are in the same element, whereas compounds, they have to be in different elements. So there's two ways that we talked about doing this, okay? Make sure that you know the difference between these. So ionic and covalent. The key word that you want to know, and again, I'm going to be looking specifically for this, is going to be what's happening to electrons. So in ionic bonds, electrons are transferred, okay? Meaning that one of them is going to gain electrons and the other one is going to lose electrons. Whereas in covalent, you are going to have you're going to have something different. So covalent, you're going to have sharing electrons. Okay? So that is the main difference here. Make sure you know what is happening in terms of electrons specifically. A lot of you guys on the quiz just talked about what types of elements form these. That's fine. I gave you credit on the quiz, but for the future, for your test, you will need to be able to talk about what is happening with electrons. So in an ionic bond, what happens is, let's say sodium ends up losing its valence electron. It has a positive charge. And then it finds a little chlorine anion, which gains that electron. And now positive and negative opposites attract. Okay? That is the main reason why ionic bonds form, is because of that positive and negative difference there. Covalent bonds are going to be a little bit different. That is where they're not necessarily going to be moving electrons around. They're just going to be sharing them back and forth. So let me show you what that looks like. So let's go ahead and make a covalent bond. Let's make it between carbon and hydrogen, and we're actually going to make 4 hydrogen bonds here, because carbon, when you draw the diagram for carbon, and we'll get to these diagrams in a second, you find out that carbon has 4 valence electrons, okay? So you're going to have 1, 2, 3, 4 on its outer layer. That means that you have 4 places where I can potentially put in a hydrogen. So what's going to happen here is hydrogen only has 1 valence. So when you draw hydrogen out, it looks something like this. So what's going to happen here is I'm going to just fill in. I'm using different colors so you can see that both of these atoms are contributing something here. They're sharing. Notice those bonds are not just coming from one thing. So the end result, you can draw this with lines, is going to be something like this. Okay? So in covalent bonds, you have electron pairs getting shared between different atoms. So they're getting shared here, 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 and here. You would have 4 bonds in that molecule. Cool? All right, so then let's look at how we would make these Lewis dot structures super quickly. Okay, so Lewis dot structures are going to be a way that we only show the valence electrons. So what is happening here with our valence electrons, and how are those going to interact? So basically, you would look at your, whatever you're drawing, you would first just do the symbol. So let's say that I'm going to do, let's do oxygen. I'm going to make an oxygen molecule. Oxygen exists as O2. Now, oxygen, if we look at a periodic table, it is going to have 6 valence electrons. So when you draw that out, you have 1, 2, 3, 4, 5, 6. Okay? Now, keep in mind, oxygen actually has 8 electrons total, but 2 of those are hidden in that energy, inner energy level. So we're only showing the outer valence ones. So this is a neutral oxygen atom. What you're going to see in O2 is that 2 of these atoms get together, and so I draw another one over here. Actually, you know what? Let me do it in a different color so you guys can see how this works in terms of something more complex. I'm going to draw red, 1, 2, 3, 4, 5, 6. So what's going to happen is these guys are going to bond. So you're going to have your oxygen here, and what's going to happen here is you're actually going to get a double bond. So you're going to get these two that are forming here. I'm not going to ask you to do double bonds on your test. I might ask you just to make sure that you know that they are a thing. Like I might have a picture of one and you have to tell me what's going on there. But I'm not going to ask you to draw any double bonding, okay? So when you draw that, I'm still going to have my valence electrons like here. Keep in mind, all you're doing is putting dots. And you want to have 2 dots on all 4 sides. If you can't do that, then you're going to have lines in between. Each line represents 2 electrons being shared, okay? So counts 2 there, and I'm going to draw another one there because the oxygen is also going to share. So you're going to get something like this, and that is what an oxygen molecule looks like. Now, you might have to draw some Lewis diagrams. What I'm probably going to do is I'll probably make part of your test on Nearpod or something like Nearpod where you have to actually draw an atom. So I might just give you an atom, like draw a Lewis diagram for carbon, and then you could just go bam, and that's all you gotta do. But I might do something like that because that's an easier way for you guys to draw and for me to track it. So keep that in mind. I don't want you to be totally caught off guard if I do ask you to draw some Lewis dot diagrams. One more thing before I move on. Honors, be looking out for a second video that will be on there about polar bonds. That's something that we talked about in the Zoom today, or you guys will see this on Wednesday, so Zoom yesterday. So make sure that you're on the lookout for that video. Okay, so here's some quick definitions. I will put a Quizlet on there for you guys to study these, but main differences here, just getting straight some of these definitions here. So a compound is when you have 2 or more atoms that are different elements that are bonded together. A molecule is when you have those 2 atoms bonded together, but they don't have to be different elements. So for example, H2O is a compound. NaCl, table salt, which I would technically want to do that. That would be a compound. That'd be an ionic compound. Methane. All of those are going to be compounds. However, if I were to talk about something like O2, if I wanted to talk about N2, something like that, those are 2 atoms that are bonded together, but they are going to be different. They're going to be the same element. Now, keep in mind, all of these that we mentioned here are also molecules. So molecules are kind of the more broad term. A compound is a special type of molecule. So compound is a type of molecule. Let me write that bigger somewhere over here. Compound is a type of molecule. Okay? So compound is a type of molecule. Keep in mind, mixtures are different from this. So mixtures are going to be when there is no chemical bond. So it's going to be different substances in the same area, but the difference is going to be how they are distributed. What I mean by that is how packed in, how are they dissolved, something like that. So for example, let's say that I have something like this. I have 2 little containers here, and inside one container I put yellow liquid and I put some blue liquid like that. This would be something like a heterogeneous mixture right here because I can pick out the parts. I can pick out the blue and I can pick out the yellow, but in a homogeneous mixture, all of that together would end up being green. So you can't pick out the yellow and the blue anymore. It's all mixed together. All right, the final thing that you need to make sure that you know is how to figure out those chemical formulas. Let me use black instead. So chemical formulas. So for example, H2O. What I'm saying there is I have 2 hydrogen atoms and I have 1 oxygen atom. Okay? If I write another chemical formula, C6H12O6, that is also telling you how many atoms are in there. So you have 6 carbons, you have 12 hydrogens, and you got 6 oxygen, okay? If you don't see a subscript, that's what we call those numbers right here that I'm underlining. If you don't see one of those, then you can just assume that it is 1. That is pretty much it. Those are kind of the main highlights of what we've been talking about the past couple of weeks. So I hope that makes sense. Feel free to go back and rewatch anything that you need to. Go back and rewatch old videos where I go into a little bit more in depth if you need to. Or if you still have questions, feel free to reach out in Zoom and we can Zoom together. All right, guys, have a good one.